Hi, this is Sunil. So today we are at another site where we are going to show you the design and installation of a solar hybrid system. So this site is in Bangalore. This is a 4.8 kilowatt solar PV hybrid system. Hybrid system essentially takes power from the solar panels, from the grid and the battery, optimizes all that to give a output. So since this is a 5 kilowatt system, we have got 10 panels of 480 watt peak each. This is high efficiency panels from sun power. So the charge controller for this system takes 145 volts of open circuit voltage. So this 10 panels are made into 5 strings. So 2 panels are connected in series and totally 5 strings are taken into the array junction box, and from there to the charge controller, which we will shortly show. This is arranged in such a way that the shadow effect on this is very minimum. As you can see, this is elevated so that the neighboring buildings do not cast shadow on these panels. So we will also show you the nameplate readings of the solar panels and then tell you how to design the array junction box and subsequent systems in the PV setup. Before getting into the wiring and the inverter details, here is a small little detail. This is the water draining clip. A detailed video about this clip is already made. It's in the description below. These are provided so that the water doesn't stay in these corners. By providing these clips, the water drains off easily, thus preventing the formation of hotspots. Now let's go down and look at the inverter and the other wiring details. So this entire thing behind me is the inverter setup. Okay, so now we will discuss about the wiring portion of the inverter. Before getting into wiring, we'll just quickly run through the components. This is the array junction box. This is the charge controller. This is the inverter. This is our incoming line from the local discom as well as the outgoing line. This is our communication box which can communicate from this inverter to the cloud, and this is an earthing box where all the earthing is terminated. So now we will discuss part by part about the wiring of this system. Broadly we can categorize the wiring into 3 components: the DC wiring, the AC wiring and the earthing. Again, the DC wiring, we can talk about the wiring from the panel to the array junction box and from array junction box to the charge controller, and from the battery to the charge controller as well as the inverter. This forms the DC part of the wiring. On the AC part, again we can make 2 bifurcations. One is the incoming line from the mains, other is the outgoing line from the mains. As I told you, hybrid system takes power from predominantly 3 sources: the solar, battery and the grid. We can use the grid or we can also run it as an off-grid mode as well. So we will now discuss in detail wiring of each of these components. We will start with the DC wiring. In the DC wiring, we will start with the solar panel wiring, that is the wiring from the solar panels to the charge controller. So as you saw on the top, we have got 10 panels. So there are 5 strings. So 2 panels are connected in series. So we will have 5 strings. So that makes 5 fuses on the positive side and 5 on the negative side. Now we will go in detail into this box and look at individual components. So as I showed you, there are 10 panels of 480 watt peak each, and 2 panels are made into 1 string, that is 2 of them are connected in series, and totally there are 5 strings. Since there are 5 strings, there are 5 fuses on the positive side, 5 fuses on the negative side. The charge controller here can take a maximum DC voltage of 145 volts. So what it means is the output from this box shouldn't exceed 145 volts. Each of these strings must also be less than 145 volts. We will now quickly measure voltage at each of the string and tell you what is the incoming voltage into the charge controller. So now this is our multimeter, we have put it into DC. Now we will measure, this is string 1. So string 1 is giving a voltage of about 80 to 81 volts. String 2 also should be giving around 80 volts. So this is our output. So we will take the output voltage. So this is our output voltage from this box. It is showing around about say 75-78 volts. For the current insulation, this is the voltage coming out of this box. So this is about the solar panel wiring. Okay. Now we will go to the next step of the DC wiring, that is the wiring from the battery box. So this is the next part of the DC wiring. This system can take 48 volts of battery, that is the system voltage is 48 volts. So these are our 4 batteries connected in series. So this gives 12 into 4, 48 volts, and this is connected into our charge controller and the inverter through these fuse boxes. These fuse boxes are very important in terms of safety. This side is the positive side of the battery, this is the negative side of the battery. As you can see, positive and negative have been housed in 2 separate boxes, so that at no given point of time this can short. If the battery shorts, it can lead to a lot of problem including fire. So these are 2 fuse boxes. I will open also and show you these boxes. Please make sure that no unauthorized persons should operate these boxes. This is very dangerous. So it's very important that this is open only for maintenance. So from the battery through the fuse, it is connected to the charge controller as well as the inverter. We will show you this wiring now. So this is our 48 volts battery, this is the fuse box. So this is the positive side of the battery, negative side of the battery. They are housed in 2 separate boxes so that they don't short. If it short, it can lead to fire. So even to operate the fuses, you need a fuse puller. It should not be, nobody should use a cutting plier to actually open or close the fuses. You can see on the positive side we have got a 200 amperes and a 125 amperes HRC fuse. On the negative side also we have got a 200 amperes and a 125 amperes HRC fuse. The 200 amperes is connected to the inverter and the 125 amperes is connected to the charge controller. This is based on the ratings of the inverter and the charge controller. So this is about the fuse box. So now let us look at the wiring inside the charge controller. We have seen 2 parts of the DC wiring, the solar panels and the battery. Now we will see where these 2 are terminated. So this is the charge controller of the system. So this are the components inside. So this is the photovoltaic system output, positive and negative of the PV system. The positive of the solar panels are connected here. The negative of the solar panel system is connected here. This also takes the input from the battery. So the battery positive is coming here and the battery negative comes here. So this is about the wiring of the charge controller. The other small remaining part of the DC wiring is the wiring into the inverter from the battery. So the battery positive also comes here through the 200 amps fuse. This is the positive of the battery and this is the negative of the battery. So now this completes our DC wiring system. From now on we will talk about the AC wiring and the other peripherals. So now we will start with the AC part of the wiring. You can refer to this diagram. Basically we are talking about 3 different types of wiring. We spoke about the DC wiring. Now we will talk about the AC wiring. AC wiring also has two parts, the input side and the output side. Okay. So the AC wiring starts from the mains panel of the house. Okay, that is where we tap a single line and get it till the inverter. We will now go to the mains panel and look at the components there and see how the wiring is done in the mains panel and how it has come till the inverter. So the AC side of the wiring starts from the main distribution panel of the house. So the incoming DISCOM power comes into this bus bar, and this is our bidirectional meter. Since this is a grid connected system, this inverter can also export power into the grid. So this bidirectional meter can record both the power taken from the grid and the power given back into the grid. So the wiring on the AC side of the inverter starts from here. So this is our main incoming line. So since it's a 3-phase incoming line, so we can see here, this is our 3-phase meter. So the meter output is connected to a ELCB, 1+2 SPD and a MCB. So after this MCB, the load goes into the house. One phase, that is the lighting phase, is taken into the inverter. So one phase is tapped from here and this goes into the inverter. So before it goes into the inverter, one phase, that is the lighting phase, from this MCB is taken into our first level of protection. Here we have a ELCB. We also have a over protection and under voltage protection relay. So before the power gets into the inverter, again we have a stabilizer on the top. So before the power gets into the inverter, it goes through one ELCB, over voltage and under voltage protection relay. Then it goes into the stabilizer and so on, which we will see now. So this is about the first part of the incoming wiring from the grid. Just to repeat, we have got a 3-phase meter, 3-phase protection. One phase from here is tapped. It first goes into an ELCB, over voltage under voltage protection relay, and then gets into the inverter through another level of protection. So we saw in the mains of the house, the main distribution panel of the house, the incoming DISCOM power goes through, because since it's a 3-phase input to the house, we have a 3-phase SPD, a 1+2 SPD, a 3-phase ELCB, a 3-phase MCB. From there, one line is tapped, it goes into the relay and another SPD there, and it comes to the distribution box. Even before it gets into the distribution box, the power gets into this servo stabilizer. The stabilized output from this stabilizer gets into the input side of the inverter. See, before the power gets into the inverter, this is the input panel. In the input panel, we have got a MCB, we have got a 275 volts SPD, we also have a ELCB. This is the meter which measures the various parameters of the input power. As I told you, this hybrid inverter can take power from the grid, the battery and the panel. This can also export power back into the grid. So this is our input side. The output from the input side of the grid gets into this terminations here. So here we have got the input, phase and neutral, and this is the inverter. Okay, this also takes power from the battery. So now the stabilized power from this inverter gets through the output terminals and it gets into the output side of this box. Here again we have got a surge arrestor or a surge protection device and a MCB, and there is a meter which is measuring the various parameters of the load, that is the current or the power factor. All these things are measured in these boxes, and a small power output is also taken here, and that gets into our communication box. Essentially this is a kind of a connection between the inverter and the cloud. This basically is a data logger. It picks up various parameters of the system and one can remotely monitor. I will quickly run through the monitoring platform. So this is the communication box which has a XCOM LAN. So this is the monitoring platform. This is the app provided by Studer. So we can see from the panel we are generating 1.35 kilowatt, out of which about 0.47 is being consumed into the house, and the rest is getting exported. So this is a nice tool in which we can even measure our production as well as consumption. So various parameters are shown here, so one can go into detail and monitor the health of the system. So this is about the monitoring. So since I told you there are AC components, there are DC components, so it's very important that we earth both these systems separately. So this is a small junction box where on one side we have earthed all the AC side, that's the inverter body and the surge protection from the AC side, and the other side we have got all the DC components, that is the solar panel structure and the SPD from the array junction box. These are grounded through this bus bar. So essentially it's very important that we keep the AC and DC earthings separately. There is also a lightning arrestor in this building that is earthed separately without touching neither the structure or any other component. It directly goes and gets grounded. So this is about the earthing and the wiring of the hybrid system. In the previous videos actually I have explained how this hybrid inverter works and what are the topologies in which this hybrid inverter works. We will quickly run through that in the coming slides so that you get a better understanding of the versatility of this inverter. The output from that inverter also comes here. Okay, so there is a meter here which actually records the output from the inverter. We also have MCBs here for protection. There is also a changeover switch. Now this is in inverter mode. In case there is a fault in the inverter, we can actually bypass it and run it even directly from the grid. If one needs to switch off the power completely, if this goes to the center, the power is off. So this is about the hybrid system that we have installed at this site. Thank you very much.